So now problem number 7. If cos y equals to x into cos a plus y, then prove that dy dx equal to cos square a plus y by sin a. How to solve it? Look at that. Given cos y equals to x into cos a plus y. So x should be cos y by cos a plus y. Now x equal to cos y by cos a plus y. So x is here, x is the dependent variable and y is the independent variable. So now we have to differentiate with respect to y. We get dx dy equal to u by v rule. So v square, that means cos square a plus y. So now cos a plus y constant and derivative of cos y with respect to y, that should be minus sin y, minus cos y into derivative of cos a plus y with respect to y, that should be minus sin a plus y. Clear? And derivative of a plus y is with respect to y is 1, so it should be minus sin a plus y. So now minus minus plus, so sin a plus y into cos y minus, this is the minus, sin y into cos a plus y. So it should be sin a cos b minus cos a sin b, that should be sin a minus b. So it should be sin, what is your a here? A plus y, minus what is your b here? Y. So y cancel out, so it should be sin a by cos square a plus y. Dx dy equal to sin a by cos square a plus y. Now take the reciprocal, so it should be dy dx and that should be cos square a plus y by sin a. Clear? Now next problem, it is if y equal to x sin y, then prove that dy dx equal to y by x into 1 minus x cos y. How to solve it? Given y equal to x sin y, now differentiating with respect to x, we get dy dx equal to derivative of this one uv rule, sin y constant, derivative of x with respect to x is 1, plus x is constant, derivative of sin y is cos y, into derivative of y is dy dx. So this one is in the right hand side and common with dy dx, that should be 1 minus x cos y dy dx, that should be sin y. So look at that, given y equal to x sin y, so sin y should be y by x. So instead of sin y, we put y by x. Clear? So now dy dx should be equals to y by, this one is there, so x into 1 minus x cos y. So it is your answer. I think the proof is completed. Now problem number 9. If y equal to root under 1 plus x to the power 4, then prove that y into y square minus 1 dy dx, that is equals to x cube. How to solve it? Given obviously root under 1 plus x to the power 4. Now squaring both sides, we got y square equals to 1 plus root under 1 plus x to the power 4. Clear? Now this one is there and squaring both sides. So y square minus 1 whole square, that should be only 1 plus x to the power 4. Now differentiating with respect to x, it should be 2 into y square minus 1 into derivative of y square minus 1 with respect to y is 2y dy dx, and derivative of minus 1 is 0 obviously, and derivative of 1 is 0, and derivative of x to the power 4 is 4x cube. I think 2 into 2 4, this 4 cancel out. So y square minus 1 into y, this y into dy dx, that should be equal to x cube only. So I think the proof is completed. Clear? That is y into y square minus 1 dy dx equal to x cube. The proof is completed now. So now we go to the next problem. Problem number 10. If root under 1 minus x square plus root under 1 plus y square, that is equal to a into x minus y, then prove that dy dx equal to root under 1 minus y square by 1 minus x square. How to solve it? We have to use parametric form for solving this equation. How to solve it? Let x equals to sine theta and y equal to sine phi. So it should be theta equal to sine inverse x and phi should be equal to sine inverse y. Now root under 1 minus x square plus root under 1 minus y square equal to a into x minus y. That should be, instead of x we put sine square theta, instead of y put sine square phi, and this x should be sine theta, this y should be sine phi. So root under 1 minus sine square theta means root under cos square theta, that is cos theta, and root under 1 minus sine square phi means cos phi. That should be sine a into sine theta minus sine phi. So now that the formula cos a cos b, that should be cos 2 into cos a plus b by 2 into cos a minus b by 2, and this should be sine theta minus sine phi. This should be 2 into cos of a plus b by 2 into sine of theta minus phi by 2, obviously. So 2 cancel out, and this cos theta plus phi by 2, this cos theta phi by 2 class cancel out. It should be cos theta minus phi by 2 equal to a into sine theta minus phi by 2. So I think this should be cot theta minus phi by 2 equal to a. So obviously theta minus phi by 2 equal to cot inverse a. So theta minus phi should be equal to 2 into cot inverse a. So what is the value of theta? Value of theta is sine inverse x, value of phi is sine inverse y. Put it here. Sine inverse x minus sine inverse y, that is equal to 2 into cot inverse a. Now differentiating with respect to x. Differentiation of this one is what? 1 by root under 1 minus x square. Differentiating this one is with respect to x is what? 1 by root under 1 minus y square into derivative of y is dy dx. That should be equal to 0. So it should be 1 by root under 1 minus y square into dy dx, that is equals to 1 by root under 1 minus y square. So dy dx should be equal to root under 1 minus y square by 1 minus x square. I think the proof is completed now. So now we go to the next problem. That's problem number 11. If y equal to, it's a very interesting problem, obviously. If y equal to root under cos x plus root under cos x plus root under cos x plus dot infinity, then prove that 1 minus 2y into dy dx equal to sin x. How to prove it? Look at that. So y equal to is given. So I think this part is, this part is root under cos x plus root under cos x plus, can I write it root under cos x plus dot plus infinity? Clear? So I think this part should be equal. So this part, only that part, root under cos x plus this part, plus this part is simply y. So y equal to root under cos x plus y. So y square equals to cos x plus y. So I think differentiating both sides, we got 2y dy dx equal to minus sin x plus derivative of y is dy dx. So this one is there and common dy dx. So 2y minus 1 into dy dx equal to minus sin x. And so dy dx equal to minus sin x by 2y minus 1. So multiply with the minus, so sin x by 1 minus 2y. So now cross multiplied, so 1 minus 2y dy dx, that should be equal to sin x. I think the proof is completed now. Is it absolutely clear? I think. So now go to the next problem. Similar problem, problem number 12, sorry. If y equal to root under tan x plus root under tan x plus root under tan x plus dot plus infinity, then prove that 2y minus 1 dy dx equal to sec square x. Similar problem, it's given y equal to root under tan x plus root under tan x plus root under tan x plus dot infinity. This should be your y, put it here. So y equal to root under tan x plus y, so y square equal to tan x plus y. Now differentiating both sides, that should be 2y dy dx, and derivative of tan x is sec square x, and derivative of y is dy dx. Now this is the left hand side, so 2y minus 1 dy dx, that should be sec square x. I think the proof is completed. Easy sum. So the next problem. If y equals to x sine a plus y, then prove that dy dx equal to sine square a plus y by sine a plus y minus y into cos a plus y. How to prove it? Given y equal to x sine a plus y, obviously. Now differentiate this one. So dy dx, and this is the u v. So this one constant, derivative of x is 1, so sine a plus y plus x is constant, derivative of sine is what? Cos a plus y, and derivative of a plus y is dy dx. Easy. So now if this one is in the left hand side and common dy dx, that should be 1 minus x into cos a plus y dy dx, that is equal to sine a plus y. So sine a plus y, obviously 1 minus x into cos a plus y. So instead of x we put, look at that, in your given question y equal to x sine a plus y. So x should be y by sine a plus y. So instead of this x, we put y by sine a plus y into this is a cos a plus y, cos a plus y. Sure. Now LCM this one. So this should be sine a plus y minus y cos a plus y, and that sine a plus y is numerator. So sine a plus y into sine a plus y, that should be sine square a plus y. I think the proof is completed. Clear? So now we go to the next problem. If sec x plus y by x minus y equal to a, then prove that dy dx equal to y by x. How to prove it? Given obviously sec a plus x plus y by x minus y equal to a, so x plus y by x minus y equal to sec inverse of a. So now differentiating with respect to x, we got x minus y whole square, x minus y constant, derivative of x plus y is 1 plus dy dx, minus x plus y constant, derivative of x minus y is 1, x minus y is 1 minus dy dx. That should be equal to 0. Cross multiply, that is 0. So x minus y into 1 plus dy dx minus x plus y into 1 minus dy dx, that is equal to 0. Now multiply it. So after simplification, we got dy dx equals to y by x, and the proof has been completed right now. So now next problem, next topic, derivative of an exponential and logarithmic functions. So look at the differentiate with respect to fx, x, that is fx equals to 5 to the power x exponential obviously minus 3 cos x plus log x. So fx is given. So now differentiating with respect to x, we get derivative of fx is f dash x. So 5x derivative of 5x is 5 to the power x is 5 to the power x into log 5 minus derivative of cos x is minus sin x, and derivative of log x is 1 by x. So the answer is 5 to the power x into log 5 minus minus plus 3 sin x plus 1 by x. Is it clear? Next problem, derivative with respect to differentiate with respect to x, 8 to the power x by x to the power 8. Consider y equal to 8 to the power x by x to the power 8. So now differentiating with respect to x, we got derivative of y with respect to x dy dx, and derivative of this one with u by v. So v square, this means x minus x to the power 8 whole square, x to the power 8 constant, derivative of 8 to the power x is 8 to the power x into log 8 minus 8 to the power x is constant, derivative of x to the power 8 is 8 x to the power 7. Clear? So x to the power 8 to the power x is constant, common, so common x to the power 8 by x to the power 16, 8 into 2 16 obviously, and the answer is 8 to the power x by x to the power 16 into x to the power 8, and x to log 8 is there minus 8 into x to the power 7. Clear? I think from this two, x to the power 7 is common, and divide x to the power 7 by x to the power 16, that should be x to the power 9. So the answer is x to the power 8 by x to the power 9 into x log 8 minus 8. Clear? So now problem number 3. Differentiate with respect to x, e to the power x plus log x by sin x. So consider y equal to e to the power x plus log x by sin x. Differentiating with respect to x, we got dy dx, that should be sin square x u by v, obviously this is your u and that is your v. So sin square x, sin x is constant, derivative of e to the power x is e to the power x, and derivative of log x is 1 by x, minus e to the power x plus log x is constant, and derivative of sin x is what? Cos x. Clear? I think sin cancel out 1, so cosec x into e to the power x plus 1 by x minus look at that. This should be cos x by sin square x, means cot x into cosec x, and into e to the power x plus log x by e to the power x plus log x. So thank you so much.